When it comes to solving rational equations, there are several steps we have to follow. The biggest and first one being that we need to factor all the denominators. Because once we factor the denominators, whether we're adding or subtracting these fractions, we do need to create common denominator. All right. In order to do that, we want to look at how all of these denominators are factored or broken down and built of. So let's take a look at our first example here. So they're going to ask us to solve, and that means get x by itself. X minus 5 over 3x squared equals 5 over 3x squared minus 1 over 3x. All right, so I can't really factor the bottoms of these, but I can see what they're broken down into, what they're made up of. All right, so this is really a 3 times an x times an x, and a 3 times x times x, and this is just a 3 times an x. So you'll notice they all share that 3. Okay, so that's common to all of them. They all share at least one x. Okay, it's probably better if I show it down here. They all share 3, they all share an x. The first two have an extra x, and this one does not. So that gives us an idea of what type of common denominator we're going to want to create. We want to create that 3x squared. In order to do that, let's see how we did that piece by piece. Now the first one already had 3x squared, so we're going to leave the top alone. There's no changing it. Same thing with this second piece. Already had 3x squared, so we'll leave the top. The last one had a 3 and an x. It needs an x. But what I put on the bottom, I need to put on the top, because x over x is just 1. We're multiplying by 1. We're changing how it looks, but we're not changing how much it's worth. So the 1 times that x on top gives me x. And now we have common denominator. And the great thing now is that once we have this common denominator on the bottom of all of them, I can cancel out all the common denominators. This leaves me everything on top, which I can now just bring down, and is a much more simple equation that we can solve. So we're getting x by itself, so let's move the x's together. So plus x on both sides gives me 2x, and plus 5 over here gives me 10, dividing by 2 gives us 5. Now later on, once we get these multiple types of answer problems, we are needing to check for these extraneous solutions, and I'll show you how this works on this one. Extraneous solutions, and I made the note right here, extraneous solutions are answers that when plugged back into the original equation create a 0 on the bottom of a fraction. Because remember, 0 on the bottom is undefined, and we can't really have undefined answers. So if I were to plug in the 5 back in here, would any of those give me a 0 on the bottom? So let's see, 5 squared is 25 times 3 is 75. I don't really care what number it is as long as it's not a 0. Same thing happens here and here. It's going to be a 15, so not a 0. So none of these actually create an extraneous situation, so that is my correct and final answer there. So let's take a look at another problem. For example, let's say they gave us x plus 3 over x equals 3 plus 2 over x. So we see this time we got a fraction equal to a whole number plus another fraction. We can make this a fraction because you know we're working with rationals here, working with fractions altogether. I can see that most of them have an x on the bottom. This one doesn't. I can multiply this one by x in order to get the common denominator of x, but what I do at the bottom, I need to do the top. So now I have x plus 3 over x equals 3x over x, because you see if I simplified or reduce those x's, it will come out to 3. But we don't want to do that. We want to actually show up like this. Now they all have the same common denominator. I can cancel them out and just write what's on top. So x plus 3 equals 3x plus 2. And now we're able to solve this out, get the x's by themselves. So I'm going to subtract x, subtract 2. So we get a 1 equals 2x, or x equals 1/2 when I divide both sides by 2. And if you want to check, plugging that back in does not create an extraneous solution, does not create a 0 anywhere, so we're okay again. Let's get a little bit more complicated, because sometimes we're actually going to run into a situation where there's more than one answer. So 3 over m squared plus 4m equals 3m plus 6 over m squared plus 4m plus m plus 1 over m plus 4. Alright, so now we're getting a little bit more complicated with our problems. I can see the first and second fraction already have this m squared plus 4m as a common denominator, but the last one doesn't. So this is where I really do want to factor stuff. So instead of this, I want the factored version, and we're going to GCF it. So factor out an m leaves me with m plus 4. Same thing here, m plus 4. And this one is just an m plus 4. Now you notice the building blocks. They all have an m plus 4. The first two also have an m. So these are all things that they're going to need. So this one also needs an m. But if we multiply the bottom by m, we're also going to need to multiply the top by m. And when we're talking about the top, the whole top. So there's two pieces there we're going to need to multiply in. So in the end, the common denominator that we were looking for was m times m plus 4, the combination of all those building blocks. Now some pieces have everything we need. Some of them need a little extra help, like that last one needed an m. See, we needed that piece, so we put it on top as well. If it already has everything, we'll just leave it alone, like the first two pieces. The last one we do need to multiply out, so we get m squared plus m. The great thing now is all those bottoms have common denominator. They're all gone now, and we'll just write out the top. 3 equals 3m plus 6 plus m squared plus m. Now looking at this one, even if we didn't have the rest of this problem, exponent 2 here tells me that there's going to be two answers. So most likely we're going to need the x factor and set this equal to 0, so let's go ahead and do that. So rearranging stuff, m squared should be first. 3m and m makes 4m, and then moving this 3 over, plus 3, set the whole thing equals 0. And it is, it's 3 pieces, so that's going to be an x factor. Top number is 1 times 3, which is 3. Bottom number is 4. So the two numbers that will multiply to give me 3 and add to give me 4 are 3 and 1. If we want to go directly to our answers, we just flip the signs of these. My first answer is -3. My second answer is +1. And we can check for extraneous solutions. So we take that -3 and -1. If I put a -3 in here, we get 1 times this -3 would be -3. Still not a 0, so it's not a problem. Same thing with the -1. If I plug it in anywhere, still doesn't create a 0, so both of these answers are okay. Sometimes when we have two answers, we might lose one as an extraneous solution. Here we were able to keep both because neither of them created zeros on the bottom. All right. Now let's take a look at maybe one of the more complicated ones we're going to see. Let's say it's n minus 3 over 3n squared plus 33n plus 90 equals 1 over 3n squared plus 33n plus 90 minus n plus 2 over 3n plus 15. Now, so far, the first two fractions do have common denominator, but we need common denominator on everything for the order to cancel. So what we're going to need to do is use any type of factoring method possible to us and simplify these, basically. So looking at these, it is 3 pieces, so eventually we'll do x factor, but before that, I see that I can GCF a 3 out of everything, leaving me with n squared plus 11n plus 30. So that one's gone. Same thing's going to happen here. The last one I can GCF a 3 out. Leaves me with n plus 5. And you see how they all share a 3 right now? So that is part of the common denominator. The last one has an n plus 5. Because you see, we can still factor these ones a little bit more. We can x factor those. Top number is 30, bottom number is 11. That's completed with a 6 and a 5. So really, instead of this, it's going to be 3 times n plus 6 times n plus 5. Same thing for this one, because it's the same polynomial. All right. So really, those are the new bottoms. So if we look at it, again, they all share a 3. They all share the n plus 5. The first two share n plus 6. The last one does not have it, so the last one needs it. Okay, so I made a little bit of mess of everything, but let's try and solve this out again. So there's a 3, n plus 6, n plus 5. 3, n plus 6, n plus 5. 3, n plus 6, n plus 5. Now that's what we all agreed on that everything needs. The first one already has all that, so we'll leave the top alone, n minus 3 from above. The second one already has that, so we'll leave it. The last one already had the n plus 2, and you'll notice the part that we introduced, the part that I circled in pink, is the n plus 6. If I put an n plus 6 on bottom, I need to put one on top. So I need to multiply to the top as well. Alright, and that's going to require some foiling out. But the best thing is, all these bottoms are now gone. So we got rid of a lot of the problem. We're left with n minus 3 equals 1. Now we do need to multiply this out. That's going to be an n squared plus 8n plus 12 after all said and done. But we've got to be careful here. This whole fraction here is being subtracted. So what that means is this whole thing here is being subtracted. So I actually need to apply that negative sign to everything now. So we got n minus 3 equals 1 minus n squared plus 8n. Whoops, not plus 8n. Remember we got to switch it. Negative minus 8n and a minus 12. Again, this time tells me that there's going to be two answers because of that exponent 2. I'm going to want to move everything to the left, so I'm going to move the n squared over. Plus 8n with this one makes it plus 9n, so all this is gone. 1 minus 12 is negative 11, then add 11 over, you get plus 8, set equal to 0. And this is something we can easily x factor. Top number is 8, bottom number is 9. The two numbers that multiply to give me 8 and add to give me 9 are 8 and 1. So when we write those answers, we flip those signs, negative 8 and negative 1. And again, we can check. If I plug both of those back in to the original, let's see. Will it create a 0 anywhere that I plug it into? Let's see. First answer was negative 8, so that's a negative 3. No, so no zeros created anywhere, no matter what we plug in. So this one, again, comes out nicely. Two answers still survive. Now, just to sum things up, basically, we want to be able to create common denominator on everything. Okay, common denominator, if everything's the same on the bottom, all those denominators will cancel out. In order to create the common denominator, we want to see what everything's built up of. So that means we have to factor sometimes or break it down to different pieces to see all these pieces. And whatever something is missing, we can introduce to that part of the problem. But if we introduce it to the bottom, we also have to introduce it to the top. So lots of different steps here. So lots of different ways to practice these, but all of them follow the same general format for solving rational equations.